Suppose that we are given the relation as follows. 3 times t, which is time, is equal to the square root of 3x plus 6. And suppose that this relation describes the displacement of a particle in one direction, where x, which is the position, is measured in meters and t is measured in seconds. Find the displacement when the velocity is 0. Okay, so to start, we want to find, right now we have a function t, which is a function of x, right? We have some t on the left-hand side, and then there's some function of x on the right-hand side. What we want to find is some x of t, right? So what we want to do is we want to invert this equation. So to do that, we take our equation. So we take 3t is equal to the square root of 3x plus 6, and then we just solve for x. So to do that, let's subtract 6 over to the left-hand side. So we get 3t minus 6 is equal to the square root of 3x. Okay, then we can square both sides. So the right-hand side becomes 3x, and if we square the left-hand side, we get 9t squared, right? So this term squared plus this term squared, so plus 36, which is 6 squared, minus 6 times 3t minus 3t times 6, right? And then this guy is equal to 3x. So, writing this, we can add these two terms together. So, if we do that and we divide each term by 3, we get this guy, or actually, let's add these two terms together first. So what we get is we get 9t squared minus 18t minus 18t. So that's minus 36t, because negative 18 minus 18 is 36, plus 36 is equal to 3t. Is equal to 3x, sorry. It's equal to 3x. Then we can solve for x. So doing that, we find that x of t is equal to, well, 9 divided by 3 is 3, so 3t squared, minus 36 divided by 3 is 12t, plus, well, 36 divided by 3 is 12, so that's plus 12. So we now have the position as a function of time. Okay, well, it asks us to find the displacement when the velocity is 0. So let's find our function for velocity. We know that v as a function of time is equal to dx dt. It's the derivative of this guy with respect to time. And that's equal to, well, taking the derivative of this, we bring down the 2, so that's 3 times 2, which is 6, and then we subtract 1 from the exponent, so that's 6t minus, the derivative of t is 1, so that's minus 12, plus, well, the derivative of 12 with respect to time is 0, so we don't add anything here. And we want this guy to be equal to 0. So now, if we take v at t is equal to 0, this is still equal to 6t minus 12. So what t gives us this equal to 0? Well, if we add 12 over to the other side, what we get is 12 is equal to 6t, and then dividing by 6, we get that t is equal to 2 seconds. So that's the first part of our answer. And using that, we can get the displacement at this time. So just plugging in 2 seconds to x of t here, we get that x at 2 seconds, which is when the velocity is 0, is equal to 3 times 2 squared minus 12 times 2 plus 12. Okay, then we get, this is 3 times 4 squared, 3 times 4 minus 24 plus 12. And then that's equal to 3 times 4 is 12 minus 24 plus 12. But this is equal to 0. So this is equal to 0. So what that means is that the displacement x at 2 is equal to 0 meters. So when the velocity is 0, the displacement is also 0. So just to reiterate what we've done, we started with this relation here, which describes the position as a function of time of our particle, and more in particular, it describes the displacement of a particle as a function of time. And then we wanted to know what was x when the velocity is 0. And we calculated that x when velocity is 0 is 0 meters. And with that, I'll end the video. Thank you.